This is R.D. Sharma solution. We are taking class 12, chapter 19. Exercise is 19.32, indefinite integrals. Now in this exercise, the main process or the starting point is to get rid of the root. So when we eliminate the root, then we can simplify the integration. Then we will apply the normal formula, like integration of 1 by x square plus a square, integration of 1 by x square minus a square, like that. So this is your integral. X plus 2, that is under root x plus 2, can be taken as some t, p or q. Or you can say that x plus 2 can be taken as t square. T equals to under root x plus 2. That simply means t square equals to x plus 2. Then you differentiate it. So when you differentiate it with respect to x, on the right, nothing will come. On the left, it will be 2t dt by dx. That is, if we want dx, that will be equivalent to 2t dt. So this integration will be formed like this. So take this x plus 2 as t square, under root t square will be t only. Now x minus 1 has to be changed in terms of what we have assumed. So dx becomes 2t dt. Under root x plus 2 becomes t. Now x minus 1 be written in this form also. What is x here? If you take this 2 on the left, x is equivalent to t square minus 2. And you have to write x minus 1, so that you have to add a negative 1. So this becomes t square minus 3. So let's write t square minus 3 here. Now tt gets cancelled. This dt integration, this t square minus 3 can be written as under root 3 whole square. That means integration of dx divided by x square minus a square has a direct result which we have proved also. 1 by 2a log x minus a divided by x plus a. Everything inside log will be inside a modulus sign. A will take as root 3. So 1 by 2a, 1 by 2 root 3 log, what is x here? T. T minus root 3 divided by t plus root 3 plus a constant of integration. Now t was initially taken as what? It was under root x plus 2. Now this replacement will do in order to write the final answer. So 1 by 2 root 3 log remains like this. T will become under root x plus 2 minus root 3 divided by under root x plus 2 plus root 3 plus a constant of integration. This is your final result. So this is the solution or reference, you can say. Most of the question of this exercise are like this only. Same way the question number 2 also needs the same logic and same process to complete. So we need to get rid of this under root. So we have under root 2x plus 3, and this 2x plus 3 can be equated to t square. So this under root t square, basically its total is your t, and we need an x also from here. Why? Because x minus 1 also has to be written in this form. So we will find out a separate x that will be put inside x minus 1 in order to get that value of for x minus 1. Next step will be the differentiation of this t square equals to 2x plus 3. So on the left, after differentiation with respect to x, 2 will come. On the right, it will be 2t dt by dx. 2 gets cancelled. So dx in this case becomes equivalent to t dt. Now whatever we have done, these three different things, we will combine them and put it here. Dx will be t dt, under root 2x plus 3 will be t only, and x minus 1, for that we need to subtract a 1 from here. So t square minus 3 divided by 2 minus 1. So this will be t square minus 3 minus 2 divided by 2. This becomes t square minus 5 divided by 2. So t square minus 5 remains in the denominator. 2 will go up. T gets cancelled. So we are integrating with the 2 outside. Dt divided by t square minus, now let's make it a perfect square, under root 5 whole square. So 1 by 2a, 2 also is there, log x minus a by x plus a. So t minus root 5 divided by t plus root 5 inside the modulus sign plus a constant of integration. So the final integration will become like this. In place of t, we will put the initial value which we assumed, and it's under root 2x plus 3. So 1 by under root 5 log modulus of under root 2x plus 3, here also under root 2x plus 3 minus root 5, and this is plus root 5 plus a constant of integration. This is your I. Now this is how you are going to go about it. So 2 questions we have done of the similar form, and this question also will take the same process and shape. And the whole idea about this exercise is to get away from this under root x plus 2 in order to replace other things in terms of under root x plus 2 if it is assumed to be some variable which you can call it as t, p or q, up to you. So this x plus 2 we have taken as t square, and you will get x from here, it will be t square minus 2. Now when you put t equals to under root x plus 2, or you can say t square is equal to x plus 2, you can differentiate it because we need to replace dx also in this terms. So 2t dt by dx will be equal to 1. So 2t dt will be equal to dx. This is the second replacement we'll do. Now we have to change this x plus 1 and x minus 1 also in place of or in terms of t. So x plus 1, x minus 1 is remaining because dx will be replaced by 2t dt, and this under root x plus 2 will be replaced by t. So let's write this x plus 1. X we have found out as t square minus 2. So just add a 1 here. This will be t square minus 1. For x minus 1 it will be what? T square minus 2, and then you subtract 1. So t square minus 3 will come. So this is t square minus 1. Denominator is t square minus 3. So 3 things we have done separately. And now we are going to combine all this. So this integration has become x plus 1 will be written as t square minus 1. The denominator x minus 1 will be written as t square minus 3. Under root x plus 2 will be t. Dx will be 2t dt. And inside an integration signature, t gets cancelled. So t square minus 1 and t square minus 3. So they both look similar. We can write t square minus 1 in terms of t square minus 3. How? If you want a negative 3, just add a negative 3 and subtract a negative 3. So t square minus 3, and the 3 minus 1 will be 2. So numerator can be written as t square minus 3 plus 2. And you can separate them in 2 parts. That is, we can form 2 different terms out of this single term. T square minus 3 in the denominator will remain the same. So this is what we are integrating. T square minus 3 differently and 2 also. But remember, this 2 will be multiplied everywhere. That is, 2 will be multiplied to the first term also, which I'll do just now. So this is integration of t. 2 is also there. I've missed writing it, but 2 is also there because 2 will be multiplied with both the terms. The second term, 2 dt divided by t square minus root 3 whole square. It is x square minus a square integration. So 2 into 1 by 2 root 2. It will give you log t minus root 3 by t plus root 3. 1 by 2a log x minus a by x plus a is the result. And since we have, as I have pointed out twice now, there is a 2 also in that integral. So we need to multiply this 2 with both the terms. So let's multiply this 2 here and 2 here. So 2 2s are 4. Now this, if you have a 4, 2 will remain. So 2 by root 3 log modulus of t minus root 3 divided by t plus root 3 plus a constant of integration. So we have included 2 twice, and there is a 2 with t also that I'll just write. So the final integration will be something like this. Let me introduce t also, 2 also with t. So 2 into what was t initially, under root x plus 2. 2 by root 3 is like this. Then we have log modulus of x plus 2 for t, x plus 2 for t in the denominator as well, minus root 3 plus root 3 plus a constant of integration. From here to here, it is the final result of this question. Now, how it needs to be written properly, this is the way you are going to go about it. So, these 3 questions were almost similar, okay? Now, this seems to be a different kind of question, but we will apply the same logic here. We need to change this under root x plus 2 or remove the under root. For that, we can have t as under root x plus 2. This t square will be x plus 2. X will become t square minus 2. Now let's differentiate both the side. 2t dt by dx, and this will become 1. So 2t dt will be dx. So dx we have got after putting t as under root x plus 2. We know what to replace for under root x plus 2, what to replace for dx. Now this x square and x minus 1 needs also some replacement in terms of t to fulfill our simplification. So x minus 1, x is already t square minus 2, just subtract a 1. So t square minus 3 can be written in place of x minus 1. What is x square in the numerator? It's t square minus 2 whole square. So we have to now replace everything in terms of t. So I will become like this. X square is t square minus 2 whole square. A minus b whole square, we will apply that formula. X minus 1 will be what? T square minus 3. Under root x plus 2 will be t only. Dx will be 2t dt. Denominator it will be t. So this t gets cancelled out. And this 2 I have taken outside. T square minus 2 whole square, as I just suggested, it will be a square plus b square minus 2ab. So t raised 4 minus 4t square plus 4 can be written like this. This 2 will use just now. So integration has become like this. T raised 4 minus 4t square plus 4. It's t raised 4, okay? There is a slight change here. 2 will be multiplied. Now the order is higher. So we need to divide this. That is t square minus 3. We have to divide t raised 4. This minus 4t square plus 4. We have to divide it with t square minus 3. So I am dividing right. This will be t square. We need a t square. For that we need a t square here. T square multiplied by t square will be t raised 4. So t raised 4 will come here. Minus 3t square. Now you can subtract these two. This gets cancelled. It will be negative t square and plus 4. Since we have negative t square, you have to multiply it with negative 1. So this will give you negative t square and plus 4. Plus 3. Now you subtract these two. So the sign will change. This first value gets cancelled and 4 minus 3 will be 1. Now how to write this? First t square minus 1 will come. Then a 1. Divided by this t square minus 3. Now everywhere 2 is already multiplied. This integration will be, let's take them as the two different terms. So we are integrating these two terms with respect to dt. So this t square minus 1 can be taken as two separate terms, integration of t square and integration of 1. So integration of t square will be t cube by 3. That is, I am doing it separately. Integration of t square dt and integration of dt. So t square plus divided by 3 will be for the first one, and then t for the second term. Now just call it as root 3 whole square here. And we can apply integration of dx divided by x square minus a square formula. So 1 by 2a log t minus root 3 by t plus root 3 formula we can apply, plus a constant of integration. Now 2 is already multiplied with all of them. So let's multiply it in order to get the final result before one step where we are going to replace t by under root x plus 2 just now. So multiply everything with 2. Now the next step will be replacement of t with under root x plus 2. So t will be written as under root x plus 2. And wherever t will come, you will write x plus 2 to the power half, because under root is to the power half only. So I'm writing the final result 2 by 3 x plus 2 to the power 3 by 2. Because it was already t cube. Then you have to put a root also, which will form half. 3 into 3 multiplied by half is 3 by 2 only. Minus twice of under root x plus 2. This is the third term, 1 by root 3 log modulus of x plus 2 minus root 3 divided by root of x plus 2 plus root 3 plus a constant of integration. This is your final result. Now how to do this? All this putting, differentiating both sides, dividing numerator and denominator has to be written by you, and the logic you have understood. Basic idea is to get under root x plus 2 change. Here also same thing. This question also just take under root x plus 1 as t square and go about. Now these questions which we are doing, this question also falls into that category. But since it seems different, we will apply the same thing here. That is, we have to get rid of this under root. So we'll put t equals to under root x. When you square both the sides, t square will be x, and if we differentiate 2t dt by dx will be 1. That is 2t dt will be equal to dx. So we have got something to replace for dx. T also we got, root x replacement will be t. How about x square plus 1? X is t square. So in order to take x square, you have to square the t square. So it will be t raised 4. Then we add a 1. So this integration in the form of t or any symbol being replaced will be of this form 2t dt. Root x will be t and x square plus 1 will be t raised 4 plus 1. The better way is to get something out of this. For time being, we are writing t raised 4 plus 1. T gets cancelled. Now, if you see this 2, if remember, we have already done a question like this. 1 plus 1 we can write x square plus 1 minus x square minus 1 like that. So we can cancel these two. In terms of t square also, we can do the same thing. Let me write it correctly and cleanly that 2 can be written as t square plus 1 minus t square minus 1. So when you open it, just to recheck, when you open this, you will again get back 2. So in place of the numerator 2, we can write this t square plus 1 minus t square minus 1. So this integration will become like this. T square plus 1 first, and denominator will be t raised 4 plus 1. Then you have a minus here. Dt is always with the integration sign. Dx and dt is always there. So this will be t square minus 1 divided by t raised 4 plus 1 dt. Now next step is quite clear to you. T square plus 1 divided by t raised 4 plus 1 already done. T square minus 1 divided by t raised 4 plus 1 already done. So we'll divide everything by t square here. Divide every term by t square. Actually, you are multiplying numerator and denominator by 1 by t square. It's similar to dividing everything by t square. So what do you get from here? Please remember and recall this because we are going to do the same question just now. So 1 plus 1 by t square will come in the numerator, t square plus 1 by t square in the denominator. For the second term, same thing will come with a negative, that is 1 minus 1 by t square in the numerator, and denominator remains the same. It will be t square plus 1 by t square. I'll just change this 1 to t square. In order to get 1 plus t square, you ought to have t minus 1 by t in the denominator. In order to get 1 minus 1 by t square in the numerator, you ought to have t plus 1 by t in the denominator. So what we will do, in order to make this as perfect square, we'll add a 2, subtract a 2. Here we'll add a 2, subtract a 2. So this will form what? This whole will utilize this negative 2. So t square plus 1 by t square minus 2 is simply t minus 1 by t whole square. 2 will remain, that will form root 2 whole square. For the second term, we need t plus 1 by t square in the denominator. So we'll utilize first 3 terms, t plus 1 by t whole square. The other term which is left is negative 2. You can write it as negative root 2 whole square. So the conclusion what we draw, or the different things which we have done, the final thing is 1 plus 1 by t square dt. In the denominator, we can write it as t minus 1 by t whole square plus root 2 whole square. The second one is negative 1 minus 1 by t square dt divided by, this will be t plus 1 by t whole square and minus root 2 whole square. Now you can take t minus 1 by t as some p, t plus 1 by t as some q. Now both sides we will differentiate. Dp by dt will be equal to 1 minus 1 plus 1 by t square. You can put this dt on left. Similarly, dq by dt we are going to differentiate here, and we will get 1 minus 1 by t square on the left. Dt also can be brought on the left. Now these two are almost similar, or they are exactly similar. So we can replace this whole by just dp. Here also the numerator can be replaced, the whole numerator can be replaced by dq. T minus 1 by t can be taken as p. P square will write in this place, t plus 1 by t. We can write q, so it will be q squared. So whole integrable content will be something like this. dp divided by p square plus root 2 whole square. Integration. The second term will be dq divided by this dq. In the denominator, you will get q square minus root 2 whole square. Negative of root 2 whole square. Now we know that there are certain formulas we have been using and employing a lot. That is integration of dx by x square plus a square. This will be 1 by a tan inverse x by a. This x will be taken as p in this case, and root 2 will be taken as a. So let us complete this first. 1 by a, 1 by root 2, tan inverse p by root 2. The second term will apply the formula of dq by q square minus a square. We can equate it with integration of dx divided by x square minus a square, because we are quite aware of this. This is 1 by 2a log x minus a by x plus a in the modulus plus a constant of integration. So we have already integrated, so we need to just replace this integration sign. In place of x, take q. In place of a, take root 2. So 1 by, I need to cancel this because we have already integrated now. 1 by 2 root 2 log modulus of q minus root 2 divided by q plus root 2 plus a constant of integration. So we will just now replace p by t minus 1 by t, q by t plus 1 by t. But remember, t also need replacement. Initially, we took t as under root x. So first p will be replaced by t and ultimately t will be replaced by under root x. So let's do it here only before we write the final answer. T minus 1 by t is root x minus 1 by root x. You can take the LCM. It will be x minus 1 divided by under root x. So this will come in place of p. So the final will be x minus 1 here and root x in the denominator. Root t is already there. Here also let's resolve this. Q minus root t divided by q plus root t. What is q? T plus 1 by t. And t was initially taken as under root x. So we'll write root x here plus 1 by root x, and this will be x plus 1 by under root x, and this is just q. We have to subtract under root 2 and add under root 2 in numerator and denominator respectively. That's what I'm doing right now. Just to make our next step easier, I'm just doing it everywhere. X plus 1 minus root 2x divided by under root x will come, and the denominator will be x plus 1 plus root 2x. Root 2x, let me write this, and there is no place left. Let's cancel this out and you know what to write here. So we will write x minus 2 root x. I'm just swapping these two terms, and x plus 2 root x plus 1 here. We will replace here. This replacement already I told you. So the final integration will be of this form: 1 by root 2 tan inverse x minus 1 divided by root 2x minus 1 by twice of root 2 log x minus root 2x plus 1 x plus root 2x plus 1 inside the modulus plus a constant of integration. That's your final result. Now how this will be written, because there is a proper formal way to solve any question, and this is the formal way you must stick to. Alright, now next question, nothing new here. First thing is to get rid of this under root x plus 1, so we'll replace it. So x plus 1 root x plus 1 can be taken as t. So this will give you t square equals to x plus 1. When you differentiate it, it will be 2t dt by dx. On the right it will be 1. So 2t dt will be equal to dx. dx replacement is done. Under root x plus 1 as t replacement is done. So we have to do something for the x in the numerator, x, which is t square minus 1, we can get it from here. And then we also have x square plus 2x plus 2. So let's replace whatever we have got. Dx I am writing 2t dt. Under root x plus 1 we are writing t. In place of x we can write t square minus 1. So let me write t square minus 1 here. X square plus 2x plus 2. X is t square minus 1. So x square will be t square minus 1 whole square minus 1 whole square plus 2x plus 1. You can take 2 outside and x plus 1 you can take, but x plus 1 is directly t square. So t square minus 1 whole square plus 2t square it has become. Now let's open this. A minus b whole square is a square plus b square minus 2ab. A is t square here, b is 1 here, and then we have a 2t square. So this cancellation, after this cancellation only t raised 4 plus 1 is being left. Tt also gets cancelled. I told you in the previous question, keep an eye on t square minus 1 by t raised 4 plus 1, because we are going to face, or we are going to witness the same thing again. So I hope that this can be solved by you. divide numerator and denominator by t square, and then find t plus 1 by t whole square in the denominator so that you can get the numerator. So this can be done by your good self, and it's the same way we have done the previous 6 questions. Now this question seems to be almost equivalent to the previous questions, but here under root x square plus 1, inside under root we always get a linear equation, but here we are not getting a linear equation, it is a quadratic equation. So we have to apply all those things which we have learned from exercise 19.1 to 19.32. 32 exercises with 60-70 questions in each of the exercises we have completed. It's a huge task. So there is experience what we got. So here we'll put x minus 1 as 1 by t. It's a different thing, but you will realize why this x minus 1 has to be equated to 1 by t. When you differentiate it, it will be negative 1 by t square. dt by dx will be 1. So if you want a replacement for dx, it will be replaced by dt by t square with a negative sign. So this equation, x square plus 1 also you need. X from here will be what? 1 by t plus 1. So you can write x as 1 by t plus 1. Now square it and add a 1. So this will be minus dt by t square. For dx I have already written. In place of x minus 1 we have taken 1 by t. In place of under root x square plus 1 we'll write what? Under root will remain the same, will not change it. But x square plus 1 will be written as 1 plus 1 by t whole square plus 1. So the integral will become like this, negative 1 by t square dt divided by 1 by t, and inside under root I am writing 1 plus 1 by t whole square plus 1. This 1 plus 1 by t whole square will apply the formula a plus b whole square, a square plus b square plus 2ab, and then along with a 1 there is a plus 1 also. Now take the LCM, you can take the highest power t square. So you'll get t square here 1, here 2t, and then a t square again. So you are getting 2t squared. You are getting a 2t along with a 1, and there is a t square in the denominator, and this is inside a root. You can take a 2 from here. When you take a 2 from here, 1 will become 1 by 2. So this denominator t square, you can take a t out because under root t square is t only. We are left with t square plus t plus 1 by 2. So now let's write it here. This 1t will get cancelled from here. Under root 2 by t, 1 more t will get cancelled. So minus dt by t is still remaining because 1 by t we have just cancelled. This under root has become t square plus t plus half. The front thing is under root by t gets cancelled. So this root 2 and negative sign you can bring in front. So minus 1 by root 2 we have brought in front. Dt divided by under root t square plus t plus half has come. Now we can make it as a perfect square, and then we can apply a formula. There is a coefficient of t which is 1. You can divide it by 2 and then square it, add it, subtract it. So we are adding half square and subtracting half square. So you can have t minus half whole square, t minus t plus half whole square also you can have. It's both the things you can have. It's up to you. I am taking the positive one, that is t plus 1 by 2 whole square. Negative 1 by root 2 remains there. dt divided by t plus 1 by 2 whole square. We have accumulated these three, collected and formed a square out of it. Half minus half square, that is half minus 1 by 4, and which gives you 1 by 4. So you can write plus 1 by 2 whole square. It's basically half minus 1 by 4, which gives you a quarter. If you subtract a quarter from a half, you'll get a quarter. Now we can apply a formula here. Integration of dx divided by under root x square plus a square has a direct result, which is log modulus of x plus under root x square plus a square. This is already, we have proven it in the earlier discussions. In this case, we will take x as t plus half and a as half, 1 by 2. So what all we have got, I am now writing it. Negative half log t plus half plus under root t plus half whole square plus 1 by 4 whole square. Now if you take, we have already taken t as what? You can keep it like this. You can just say that this is the answer with t equals to 1 by x minus 1. If you remember, x minus 1 was 1 by t. So t will be 1 by x minus 1. So you can replace t as 1 by x minus 1 here. Because t plus half whole square plus 1 by half or 1 by 4 whole square after putting t as 1 by x minus 1 will eventually give you under root x square plus 1 only. as we have seen in the previous discussions. So I'm just saying that either you can write in the first way, or you can replace t by 1 by x minus 1 plus half by 1 by x minus 1 plus half whole square plus 1 by 4 whole square. That is going to give you x square plus 1 eventually. So it was a different kind of question, and as I told you, this is also a way to show that okay, we have come up till now. So in this question there will be a different approach. First we need to get rid of the under root. If it is easier, then we can do, because the linear equation inside a root can be easily converted, but this is a quadratic equation. So we'll do something with this x plus 1. We'll take this x plus 1 as 1 divided by t. So the t will become 1 divided by x plus 1. Let's differentiate both the sides. Left will be 1. We are differentiating with respect to x. So negative 1 by t square dt by dx will come. So from this we are getting dx. If you take dx on one side, the remaining content on the right hand side will be negative dt divided by t square. Now we have to convert this x square plus x plus 1 in terms of x. See, x plus 1 is already 1 by t. X will be 1 by t minus 1. X square will be 1 by t minus 1 whole square. So this integration will be like this. First thing, we got dx. We can write negative dt divided by t square. Then we have x plus 1. We can write it as 1 by t. Under root x square plus x plus 1. In place of x square, we can write 1 by t minus 1 whole square. And in place of x plus 1, we can write 1 by t. So what is the benefit? Let's square it. A minus b whole square we are applying. A square plus b square minus 2ab. And then we have 1 by t also. This will be 1 by t square. 1 by t minus 2 by t will be negative 1 by t. And this is 1. Now take the LCM, t square. This will be 1. This will be t. And this is going to be t square. And this is inside the root. So when you take it inside the root, the denominator t square will come out. So only one t will remain, and this t square minus t plus 1 remains like that. So this t square and t square will get cancelled. So the integration has become like this. Negative we are taking outside, dt divided by t square minus t plus 1. Let's make it as a perfect square. So the coefficient of t we take, divided by 2, square it, add it and subtract it. That is 1 divided by 2 whole square will be added, and this same will be deducted also. So a square plus b square minus 2ab. So t square plus half square minus t will become t minus half whole square. Then we have 1 minus 1 by 2 whole square, that is 1 minus 1 by 4. That gives you 3 by 4. In order to write it as a perfect square, you can take root 3. Denominator is 4, that is 2 square. So you can write it as root 3 by 2 whole square. So the denominator has become t minus half whole square added with root 3 by 2 whole square. There is a square also here. Now we have a formula. What is the formula? Negative remains like this. It will be log x. In this case, x is t minus half. So t minus 1 by 2 will be x. This will be the first thing. Then plus, and inside this root, whole this t minus half whole square plus root 3 by 2 whole square will come. And if you remember, this was nothing but t square minus t plus 1. So you can just write t square minus t plus 1. So as I suggested, we can just write t square minus t plus 1 in this place, because we have added half square, we have subtracted half square, and then we have arrived to this particular under root. So t square minus t plus 1 will replace t minus half whole square plus root 3 by 2 whole square. So let me write this. T square minus t plus 1, and this t minus half is also there. So we'll replace now t. So this final result will be something like this: minus log, inside the modulus sign, it will be t minus half plus under root. I told you that you can write it as t square minus t plus 1 plus a constant of integration. Now if you remember, x plus 1 was taken as 1 by t, so t will be equal to 1 by x plus 1. So minus log modulus of 1 by x plus 1 minus half you can write. You can keep it like that. Don't worry about resolving it. And t square minus t plus 1 will give you what? You can write 1 by x whole square minus 1 by x plus 1 and plus 1. So when you resolve this, the final result will come like this. You already know the numerator was from the denominator, that is in the question the denominator is x square plus x plus 1 that has come, and x plus 1 come held in the denominator. This is your final result. I hope you will be able to resolve this to find this one, the second part. So whatever we have done is presented to you. You can follow this. X plus 1 equals to 1 by 2 is a new thing which we learned here, and how to resolve this we have taken our previous experiences also. 1 by x square minus 1 under root x square plus 1. Now we have a quadratic equation. So would you like to take this under root x square plus 1 as some t, or rather take this x equals to 1 by t. So this x equals to 1 by t will be somewhat easier. When you differentiate both sides, 1 will be equal to negative 1 by t square dt by dx. So dx you are going to get dt divided by t square in negative sense, negative sign. Dx you got. Now we have to write x square minus 1 and x square plus 1 in terms of this x, which is 1 by t. So when you square it, you'll get 1 by t square. So this integration will become like this. In place of dx, let's write negative dt by t square. X square minus 1 will be 1 by t square minus 1, and under root x square plus 1, that is, you can just write 1 by t square plus 1. So what is the benefit? I'm writing this here. This 1 by t square minus 1 will be 1 minus t square by t square. 1 plus t square by t square for 1 by t square plus 1. 1 t can come out. Now the integration will become like this. Integration of negative dt by t square divided by 1 minus t square divided by t square actually, and 1 plus t square divided by t. So you have a t cube in the denominator, t square in the numerator. So 1 t will still remain, but when it goes up, it will form t dt. Now you will say that the same question, it was same, you just changed x into t. But if you remember, or if you witness, this t has come a new one. So we have introduced a t in the numerator, because if x would have been there, you could have taken x square equals to t, differentiated, and finally it's easily resolvable. Same thing we have adopted here. This t has come in the numerator. So please do not take t square equals to p or some value. Take under root 1 plus t square equals to some u. When you take this, 1 plus t square will be equal to u square. And then what will be 1 minus t square? First you have to differentiate this also. Let me differentiate it first. 2u du by dt on the right, and this will give you 2t. So you can just cancel this 2, and then t dt will be equal to u du. So we have got the numerator now. T dt, that you can write it as negative can be taken outside. T dt can be written as u du. So let's write this u du here in the numerator. In the denominator, under root 1 plus t square was already taken as u. So let's write u in place of under root 1 plus t square. So 1 minus t square also we are going to change in terms of u. So 1 plus t square is u square, t square is u square minus 1. And 1 minus t square is 1 minus u square minus 1, and that will give you 1 minus u square plus 1. So that will be 2 minus u square. So let's write 2 minus u square here. Now this u in the numerator and denominator get cancelled. So just have to resolve or use the formula of integration for du divided by 2 minus u square. 2 can be written as under root 2. So du divided by under root 2 whole square minus u square is the final result. So one more thing you could have done. This negative is already there. So you could have written it as u square minus under root 2 whole square. So this is up to you, that if you want to go along with du by under root 2 whole square minus u square, or u square minus under root 2 whole square with a negative sign fixed or removed. But we'll use the normal way. We'll keep the negative outside. We'll just talk about that. So du divided by under root 2 whole square minus u square we are going to employ. So it will be 1 by 2a. A is root 2 here. Log, and when you have a's, a square minus x square, a plus x will come in the numerator, a minus x will come in the denominator. A is u here, and a is root 2 here, and x is u here. But u was taken as under root 1 plus t square, if you remember. This is negative 2 root 2 log modulus of u can be written as under root 1 plus t square plus root 2 divided by 1 plus t square minus root 2 with a modulus sign plus a constant of integration. And one more thing is remaining, because t was taken as x, 1 by x. So t is 1 by x because x was taken as 1 by t. So what are you going to get? 1 plus t, in place of t write 1 by x square. So you'll get x square plus 1 by x square, that is x square plus 1 in the under root divided by x. So when you put it here, root x square plus x and plus a root 2 divided by under root x square plus 1 divided by x minus root 2. So you can take the LCM under root x square plus 1 plus root 2x in the numerator and denominator under root x square plus 1 minus root 2 divided by x. You can cancel these two x's and keep it here. So the final result will be negative 1 by, final I am writing, negative 1 by 2 root 2 log modulus of under root x square plus 1 plus root 2x from here I am taking after resolving, and this is under root x square plus 1 minus root 2x plus a constant of integration. This is your final result. So this is how we are going to solve it. It was a kind of tricky question because first you have to take x equals to 1 by t, then 1 plus t square as u square, then only you are able to solve this. Now this seems to be a very easy question because there is one more question in the last. So you just notice how we solve this question. First you take t equals to x squared. So when you differentiate this, dt by dx will be equal to 2x. That means 2x dx will become dt. X dx will be dt by 2. Now we have got the numerator. We will change the denominator accordingly. X dx can be written as dt. Half I am taking outside as we have been doing in many questions earlier. X square is t, so t plus 4 here. Under root t plus 1. Now we need to get rid of this under root. That was the basic idea when we started this exercise. So this is a linear equation. We can go along with this. Under root t plus 1 equals to some p. So t plus 1 will become p square. That is t will be equal to p square minus 1. So let's differentiate this. 2p will be equal to 2p dp by dt will be equal to 1. So this dt can be written as 2p dp. So the integration has become, after all these replacements, 2p dp t plus 4. So you can just add a 4 to p square minus 1. Whole under root t plus 1 has taken p for replacement. And this t plus 4 is p square minus 1 plus 4. This will be p square plus 3. But root 3 square can be written because we want a square. Now this p and this p get cancelled. 2 gets cancelled from 2 outside. So dp divided by p square plus root 3 whole square, and 1 by a tan inverse x by a is the direct result which we have seen earlier also. A will be taken as root 3 and x as p. So 1 by a, 1 by root 3, tan inverse x by a, that is p by root 3. Now what was p? P was taken as under root t plus 1. So P was under root t plus 1. But what was T? T initially was taken as x square. So under root x square plus 1 can be placed in place of P. So we have final answer I as 1 by root 3 tan inverse under root x square plus 1 divided by root 3 because it is inside the root only. They both are roots. Now this question has been done previously, but we would like to revise it. 1 minus x square. So when we put x equals to 1 by t, then we'll differentiate it. So we'll get dx by dt equals to negative 1 by t square. That means dx will be equal to negative 1 by t square into dt. So this dx we can replace. Now all the x has to be replaced with 1 by t. So the integration will be something like this. In place of dx we will write negative dt divided by t square and 1 plus x square. Let me do it here. 1 plus 1 by t square. This is your first term. The second term will be 1 minus 1 by t square. Let's resolve it first and then we'll put it in the denominator. So this will be t square plus 1 divided by t square. Inside the root we'll get t square minus 1 by t square. And since the denominator is t square under root, so we can just take it out. You can write it as t. So let me write this final thing, t square plus 1 divided by t square into t under root t square minus 1. Now this t square gets cancelled and this t goes up. So we have t square plus 1 and t square minus 1 in the denominator. So this integration after all this replacement and resolution in terms of t will be t dt. This goes up because t dt remains, negative we have taken outside. This will be t square plus 1 multiplied by under root t square minus 1. So one more replacement is required, or you can say this t square differentiation will directly give you t. For that we can take t as some u or this t square as some p. So when we differentiated this, the best way is to write t square minus 1 as u square. You will see in the next question. But I'm just taking this u as t square because it is solvable with this also. So t dt will be du by t. So you can write du by 2. This 2 can be taken outside. Negative remains outside. T square plus 1 will be what? U plus 1. And this under root t square minus 1 will be under root u minus 1. Now what do you think? Is there any use? I told you, you can take it here, but there is an issue. You have to again resolve it with u minus 1 equal to some p square. So rather than taking this u as t square, let's take this t square minus 1 as a u square. So here is a slight correction, or you can say I showed you what is the mistake. T square taken as u will land us into trouble. So let's take t square minus 1 as u square. Now these all is now, you can assume it to get vanished. Now u square is differentiated, so 2u du by dt on the right and t dt on the left, because 2 gets cancelled. So now I am not taking these two, but rather I am taking this u du in place of t dt, and in place of t square plus 1 and under root t square minus 1. Under root t square minus 1 will be directly u, and t square plus 1 will be what? Because t square will become u square plus 1, you write u plus 1, that is you have to add 1. So this becomes t square plus 1 will become what? It will be u square plus 2. So this u square plus 2, if you write, rather let's take 2 as under root 2 whole square. So this is a different term, this u is a different term. Just cancel these two out. Minus is outside. So let me write it clearly now. So the integration has become something like this, negative outside, du divided by u square plus root 2 whole square, and dx by x square plus a square. Integration will be 1 by a tan inverse x by a. So 1 by root 2, minus is already there, tan inverse u by root 2. Now what was u? U square was t square minus 1. So u will become t square minus 1 under root. But t was also taken as something in the beginning. X was 1 by t, so t will become 1 by x. So this u will become 1 by x square minus 1. This will be 1 minus x square divided by x square under root. Now we have u by root 2. So this u will be multiplied by 1 by root 2. So root, anything which is inside root, two things can be multiplied. So let me write it finally, negative 1 by root 2 tan inverse. Under root 1 minus x square will remain like this, and in the denominator it will be again inside the root, but it will be 2x square plus a constant of integration. This is your final result. Now how it will be done? Because all this writing is important, putting all these things are very important, because English, this is a question, and when you are solving you have to make it understandable to the examiner. Now under root x square minus 4, we have just known how to do this. First is x equals to 1 by t. The first thing is to be done like this. So this dx will be equal to negative dt divided by t square, which we have earlier done also. This integration will become, in terms of t, negative dt by t square for dx, 2x square plus 3. So 2x square, x square will be 1 by t square from here. So 2 into 1 by t square here, and plus 3. So just solve it, 2 plus 3t square by t square. So this one is done. Coming to the next part, under root x square minus 4, 1 by t square minus 4. This will become 1 minus 4t square divided by t square. Now since the denominator is under root and it is t square, you can take this t outside. So it will be 2 plus 3t square divided by t into t square under root 1 minus 4t square, all in the denominator. You can cancel this t square and t square, t goes up now. So this minus you can take it outside, it will be negative outside, t dt, t goes up, 2 plus 3t square under root 1 minus 4t square. Now in the previous question I told you that if you take this t square as say some p or u, then you will get t dt for sure. But we need to get this under root 1 minus 4t square or 1 minus 4t square such that under root gets eliminated. So 1 minus 4t square will be taken as u square. 2u du by dt will be equal to negative 4 2t. 2 gets cancelled. U du became minus 4t dt, but we need t dt. So let's bring this negative 4 on the left hand side in the denominator. So negative u du by 4. So we could have taken this u as p, because see, in my handwriting, u and 4 are looking same. So you could have taken it p, but let it go on. So t dt will put this one minus u du by 4. So minus 1 by 4 you can take it outside, because minus is already there outside. Minus will become plus. So only 1 by 4 will come in front. U du in the denominator, this whole has become, because we have already taken 1 minus 4t square as u square, and the under root of 1 minus 4t square will be simply u. So I'm writing it first. Now 2 plus 3t square will form what? We have to bring this t square from here, because we have assumed u square as 1 minus 4t square. So we have to write this t in terms of u in this case. That's what I'm doing right now. So t square will become 1 minus u square by 4. So 2 plus 3 into 1 minus u square by 4. Now take the LCM. 8 plus 3 minus 3u square by 4. So 11 minus 3u square by 4. So u gets cancelled. You get 11 minus 3u square by 4. But it is in the denominator. So this 4 will go up and it will get cancelled by 4. Now let's take this 3 outside. From 11 minus 3u square, I am taking 3 outside from the denominator. I am saying it will be 11 minus 3u square, because I told you 4 will get cancelled. If you take 3 common, it will be 11 by 3 minus u square. That's why this 3 was taken outside. So we have 11 minus 3 minus u square. But since it is u square, we want to make it as a perfect square. So it will be under root 11 by 3 minus u square. So let me write it clearly now. So we have arrived till here, I equals to 1 by 3 integration of du divided by, I took 3 outside, that's why we have made this 11 by 3 as perfect square, minus u square. So integration of dx divided by a square minus x square. What is this? You already know. So this will be 1 by 2a. So it's a is under root 11 by 3 here, log, plus in the numerator minus in the denominator. So log under root 11 by 3 plus u, under root 11 by 3 minus u, and this inside the modulus plus constant of integration. So this 3 is already there, so you can just cancel 3 from here. 2 under root 11. Actually it's under root 3, sorry. It's under root 11 by under root 3. So this under root 3 can be multiplied numerator denominator of the denominator. So this 3 will come, root 3 will come in the numerator for the denominator. That means root a into root b can be written as root ab. So this 3 and 11 can be multiplied inside the root. It will give you 33 inside the root, and 2 is outside. So what are you going to get? 2 under root 33 outside, inside the log. Let's resolve this first. So I am resolving the inside of log. So under root 11 plus under root 3 is in the denominator, so it will be multiplied by u divided by under root 3. Then we have under root 11 minus u root 3 divided by root 3. This gets cancelled. Now you have to replace, because you cannot keep u. You have to replace this u, because u square was taken as 1 minus 4t square, if you remember. So this will be under root 1 minus 4t square, and under root a into under root b is under root ab. So you can multiply 3 with 1 minus 4t square. So I am writing now after multiplication of 3 with 1 minus 4t square. Under root 11 will remain same, but after that plus and minus in the numerator denominator respectively, the same content will come, which is 3 minus 12t square. So 3 minus 12t square will come. Denominator also 3 minus 12t square will come inside the modulus sign plus constant of integration. Now one more replacement is required, because x was taken as 1 by t square. So we need to do that one also. So just replace now t by 1 by x, because x was taken as 1 by t earlier. This will be under root 11. I'm just showing you the inside one, inside the log. So under root 11 plus 3 minus 12 by x square. Same here, under root 11 minus 3 minus 12 by x square. Let's take the LCM. First 3 minus 12x square will be 3x square minus 12. In the denominator it will be under root x square, which will form x square, x only, because it is under root. So after resolution this will become, I am doing this one, the second part, 3x square minus 12 by x square. X will come out, so 3x square minus 12 by x. And this has to be added and subtracted with under root 11 preceding it. So under root 11 plus this one and under root 11 minus this one. So x multiplied by root 11 will give you x root 11. So I'm writing the final answer now. 1 by twice of under root 33 is already there. So let me write under root 33. It's not root 3, it's under root 33. Please remember, there is a slight change here. Log x under root 11 plus under root 3x square minus 12 will come. Same thing you have to write with a negative sign in between. And the preceding number or the coefficient is 1 by 2 root 33, not 2 root 3. So we have replaced t in terms of u, then we have replaced everything in terms of x. So how to do this? So it's a good question because it worth 4 to 5 marks. You can do it in this way. Now next question already been done in the previous few questions, but it's like a revision. You can just understand that x square will give you x after differentiation. We take alias when there is nothing in the numerator, but we know that x square will give you directly x after differentiation. So let's take t equals to x square, dt by dx will be equal to 2x, dt by 2 will be equal to x dx, which is in the numerator. Now let's take the replacement things. So this I will be equal to, after all these things, dt by 2, 1 by 2 I am taking outside. This will be t plus 4 and this will be under root t plus 9. Now I told you this under root has to be eliminated. So this t plus 9 can be taken as some u square, or you can say just under root t plus 9 can be taken as u or p. So we just take it as some u or p. I'm taking it as p. It's just a letter p, u, anything you can take. So actually we have taken t plus 9 as p square. So whenever we need t, we'll write it as p square minus 9. Let's differentiate it now in terms of, because remember we need dt. So we have to differentiate with respect to dt. So left is 1, 2p dp d by dt on the right. So dt will be equal to 2p dp. So this integration will become 1 by 2. Integration of dt will become 2p dp. This whole under root t plus 9 was taken as p. T plus 4, I told you t is p square minus 9. Just add a 4 so that you get t plus 4. So p square minus 5 will come. So we don't want to write this negative 5. We'll write it as under root 5 whole square. So p into p square minus root 5 whole square will come. P gets cancelled, 2 gets cancelled. You just have to integrate dp by p square minus under root 5 whole square. So you have dx by x square minus a square formula you can apply. So this will be 1 by 2a. A is what? Root 5 here. In place of x, we'll take p. So 1 by 2 root 5 log modulus of u minus root 5 by u plus root 5. Actually, we have taken p. So it should be p actually. So I told you p and u can be taken interchangeably. It's up to you. Whichever value you take, stick to it for all of the solution. Now p is under root t plus 9. And t was taken as x square in the earlier stage of this solution. So let's solve this inside one because this is only remaining. I'm writing under root t plus 9 in place of p. So under root t plus 9 minus root 5 divided by under root t plus 9 plus root 5. T can be taken as x square. So x square plus 9 under root minus root 5 divided by under root x square plus 9 plus root 5. Now we can replace this entirely and final answer will be this only. 1 by 2 root 5 log of modulus. Now after all the replacement, this will be x square plus 9 minus root 5 divided by under root x square plus 9 plus root 5 plus constant of integration. This is your final result. Now how to do this? This is very straightforward question if you have understood the previous questions. This is all about this exercise. Thank you so much. Have a good one.